Welcome to the Sleepy Oceanographer, where curiosity floats gently beneath the waves. Tonight, we're drifting into one of the ocean's most magical mysteries. Why do some fish produce their own light? Have you ever wondered what it would be like to glow in the dark, just like a jellyfish or the deep sea fish? Is it to attract prey, communicate, or maybe hide from predators in a glowing disguise? Let us know what you think in the comments below. And while you're at it, tell us where in the world you're watching from. We love knowing where our sleepy sea explorers are tuning in from. Now, close your eyes, or keep them half open as we begin our peaceful dive into the glowing wonders of the sea. Imagine yourself drifting quietly beneath the surface of the ocean, your body weightless in the cool embrace of the water. With every gentle wave, the sunlight above begins to fade. The blue of the sea darkens, becoming deeper and deeper, until eventually it disappears. You descend further, into a place where the sun's rays can no longer reach, a realm beyond light, beyond day, beyond anything familiar. This is the deep sea here. Darkness is not just a backdrop, it is everything. It fills the water like ink, enveloping every space in silence and mystery. You might expect it to be empty, silent and still, like a forgotten cave. But if you wait, something magical happens. Out of the black, a tiny spark flickers, then another, then a soft glow, like a distant lantern floating alone in the void. Before you realize it, the darkness is no longer empty. It's sprinkled with points of light, blinking on and off like stars in the night sky. Except these stars are alive. Fish, jellyfish, plankton, all glowing gently, as if the ocean had swallowed the stars themselves. This is no illusion. It's a real phenomenon known as bioluminescence. And it turns the pitch-black ocean into something that feels almost sacred, like an underwater dream. There's no electricity here, no batteries, no fire, just the pure chemical light made from within the creatures themselves, a soft, cold glow that doesn't burn, doesn't flicker, but simply appears. Imagine walking through a forest at night, and every tree, every flower, every animal has its own quiet little lamp. That's what the deep sea feels like, but slower, gentler, and more ancient. In this world, light means life. It's a tool, a weapon, a disguise, but it's also beautiful, something that stirs the soul, even when seen through science. These tiny living lights pulse and shimmer with rhythm and purpose, some blinking like a heartbeat, others glowing in waves like breath. Many of these creatures are no bigger than a fingernail. Yet in the vast dark ocean, even the tiniest spark becomes a beacon. In this place, even the smallest light matters. As you float in this glowing night, it's easy to forget the world above. There are no clocks here, no cities, no noise, just the sound of your breath and the quiet swirl of water. The glowing fish pass by slowly, like stars drifting through space, unhurried, untouched by time. Some flash only once and vanish. Others follow patterns, glowing in sequences as if sending secret messages in Morse code. And as you watch them, a strange feeling begins to rise. A sense that you've left the world of ordinary things, that you're floating through something ancient, something that's been glowing quietly in the dark long before humans ever saw it. It's humbling, it's soothing, and it's real. Down here, in the black silence of the ocean's deepest places, nature has found a way to create its own nightlight, not for us, but for the creatures who call it home, and in doing so it's gifted us with one of the most peaceful wonders of the natural world. Welcome to the glowing heart of the sea. Let's stay here a while. What exactly is the gentle, glowing light we see deep beneath the waves? How is it that creatures with no electricity, no wires, and no light bulbs can shimmer so softly in total darkness? The answer lies in one of nature's most fascinating phenomena, bioluminescence. Bioluminescence is the ability of living organisms to produce their own light. It might sound like something from a fantasy novel, but it's entirely real and surprisingly common. In fact, the deep ocean is one of the most bioluminescent environments on Earth. While we humans light up our world with lamps and screens, ocean creatures have developed their own inner lanterns through millions of years of evolution. The word bioluminescence comes from two roots: bio, meaning life, and lumen, meaning light. Life and light woven together. And unlike the warm glow of a fire or the heat of a light bulb, the light made by living creatures is known as cold light, meaning it gives off almost no heat at all. It's gentle, efficient, and perfect for the fragile world of the deep. So how does it work? At the heart of bioluminescence is a beautiful dance of chemistry. Inside the cells of these glowing creatures are special molecules, most commonly called luciferin. This molecule is the star of the show, the one that actually produces the light. But luciferin can't do it alone. It needs a partner, an enzyme known as luciferase. When luciferin and luciferase meet, often in the presence of oxygen, a chemical reaction takes place. Energy is released, but instead of producing heat, it produces light. Soft blue light, green light, sometimes red or violet, depending on the species. In many deep-sea creatures, the light tends to be blue-green, because those wavelengths travel best through water, reaching farther in the dark. Think of it as a kind of biological spark, not a burst of fire, but a shimmer, a whisper of light rather than a shout. Some creatures carry these chemicals inside special glowing organs called photophores. These are like tiny windows in the body where the light can shine through. Others don't produce the light themselves at all. Instead, they host glowing bacteria in symbiotic relationships. The bacteria do the glowing and the host provides a safe home in return. It's a quiet partnership glowing gently in the deep. One of the most amazing things about bioluminescence is how controlled it can be. Fish like the flashlight fish can turn off their light by covering their glowing organ with a flap of skin, like pulling down a curtain. Some squids can flash rapidly in patterns, almost like sending a glowing message. Others pulse slowly, letting their bodies light up in waves, like breathing in colour. Even tiny plankton, almost invisible to the eye, can flash when disturbed. You might have seen them yourself, glowing specks in the wake of a boat or sparkling around your feet as you wade into a tropical sea at night. These microscopic lights are often the first glimpse humans get of bioluminescence, and they leave a lasting impression. But this glowing power isn't just beautiful, it serves real, essential functions. Creatures use bioluminescence for many reasons: to attract mates, to lure prey, to confuse predators, or even to communicate in total darkness. Some use it to light up their surroundings, like a built-in flashlight. Others use it like camouflage, blending in with faint light from above. And all of this happens without sound, without shouting, without any harshness. Just quiet, natural light. Light that doesn't disturb, light that simply exists. There is something deeply soothing about knowing that the ocean, so often portrayed as cold and dark, holds this glowing secret. That life has found a way not just to survive the darkness, but to shine within it. Bioluminescence is not just a scientific fact, it's a kind of poetry written in chemistry, a soft miracle hidden beneath the waves. As you imagine the slow movement of glowing creatures in the deep, think of the simple wonder of it. No batteries, no screens, just life, creating its own gentle light, in a place where no sunlight reaches, a gift of nature quietly shining in the silence, and that's the quiet mystery at the heart of bioluminescence. Close your eyes and imagine descending slowly beneath the ocean's surface. At first, everything is bright and familiar. Sunlight sparkles on the waves above you, dancing across your skin and lighting up the world in shades of turquoise and gold. You can still see clearly, The outlines of fish darting by, coral reefs glowing with colour, rays of light filtering down like golden ladders from the sky. But with each passing metre that light begins to fade. The colours start to drain away. Reds are the first to vanish, swallowed by the water. Then oranges, yellows and greens begin to dim, replaced by deepening shades of blue. That's because water doesn't let all light through equally. It absorbs the longer wavelengths of colour quickly, leaving only blue to travel farther. The world begins to feel quieter, colder, more mysterious. At around 200 metres below the surface, known as the twilight zone or the mesopelagic zone, the change becomes undeniable. It's dim here, like the last hour of dusk before night fully falls. You might still see some light from above, but it's weak and blue-toned. Shapes begin to blur, shadows become your companions, everything around you starts to move more slowly, more cautiously, and deeper still, even that faint glow disappears. Beyond 1,000 metres, you enter what scientists call the midnight zone, the bathypelagic. Here, sunlight is gone completely. No matter how wide you open your eyes, the darkness remains. There is no day and no night. It is a place of eternal blackness, a place where most humans have never been, and most never will. But despite the complete absence of sunlight, the deep sea is far from empty. In fact, it is one of the most densely populated ecosystems on Earth. Millions of organisms thrive in this strange realm, not just surviving the darkness, but depending on it. Darkness here is not frightening. It is normal. It is peaceful. In the upper ocean, creatures rely on vision to find food and avoid danger. But in the midnight zone, light becomes rare and precious. Our eyes, if they exist at all, are often enormous, adapted to catch even the faintest glimmer. Or sometimes they're absent altogether, replaced by other senses. Touch, pressure, chemical cues. The deep-sea world is one of extremes, of subtlety, of quiet strategies. It is also unimaginably vast. This lightless part of the ocean, stretching from 1,000 to over 6,000 metres deep, covers more than 60% of Earth's surface. That's right, most of our planet lies in perpetual darkness, and yet in that darkness life has flourished. Creatures with delicate, jelly-like bodies drift slowly through the black, conserving energy. Fish with glowing lures or transparent skin navigate the quiet, patient as shadows. Giant squid, never fully seen alive until recent years, roam the inky abyss in silence. Here, pressure is intense, hundreds of times greater than at the surface, and temperatures hover just above freezing. But these harsh conditions don't stop life, they shape it. Evolution in the deep sea has given rise to some of the most bizarre, beautiful and haunting forms on the planet. Creatures with mouths full of needle-sharp teeth, with skin that reflects no light at all, with organs that glow like lanterns or spark like fireflies. Even in this blackness, light exists, not from above, but from within. Bioluminescence becomes the only source of illumination, like stars in a vast underwater sky. But unlike stars, these lights move. They flash, they pulse, they vanish. Some dangle from fleshy stalks, some blink from bellies, some shine from bacteria that live inside the bodies of their hosts. These tiny flickers are messages, warnings, traps, and guides written in the only language that works here, light in the dark. For a human being, the deep sea is difficult to imagine. We're creatures of the sun. Our lives revolve around its rising and setting, around the rhythms of light and shadow. But the deep ocean knows no sunrise. It knows no seasons. It exists in a kind of eternal now, still, dark and slow. And yet, despite its silence, it breathes. The water moves in ancient, powerful currents. Particles of falling matter, dead plankton, bits of algae, microscopic debris drift down like underwater snow, feeding the creatures below. This marine snow becomes a lifeline in a place where sunlight can no longer provide energy. Life down here is built not on photosynthesis, but on patience, efficiency, and adaptation. Some animals wait weeks between meals. Some live for years without being seen by human eyes. Many glow softly, using their light as a language, as a shield, or as a sword. And so in the deepest, darkest part of the ocean, a place that seems lifeless at first glance, we discover something truly extraordinary. Not just life, but light-born life. Creatures that do not merely survive the dark, but embrace it, illuminate it, and use it to their advantage. The deep sea reminds us that even in places where we expect nothing, no warmth, no hope, no colour, life finds a way. And often it does so quietly, gently, and beautifully. So the next time you gaze up at the stars, remember this. Beneath you, far below the surface of the sea, there is another sky, just as dark, just as vast, and twinkling with 1,000 living lights. To understand how fish and many other sea creatures can create their own light, we must take a gentle step into the world of marine chemistry. Because beneath the wonder and mystery of glowing creatures lies a precise, fascinating process that feels like a kind of underwater alchemy. Imagine a fish drifting silently through the pitch-black ocean, invisible to the outside world. But then, as if flipping on a switch, a small glow begins to shine from its body, a soft, natural light, neither too bright nor too dim. This light doesn't come from batteries or wires. It comes from within. The fish is creating it using special molecules that exist in perfect harmony. At the heart of this magical glow are two key ingredients, luciferin and luciferase. Luciferin is the light-producing molecule. It is the fuel, the substance that, when it undergoes a chemical reaction, releases energy in the form of light. The name luciferin comes from the Latin word lux, meaning light, and it has nothing to do with anything dark or sinister. In fact, it is quite the opposite, a symbol of illumination, of brightness in darkness. But luciferin cannot shine on its own. It needs help, and that's where luciferase comes in, an enzyme that acts like a spark or a match. When luciferin meets luciferase, a reaction begins. Add a little oxygen to the mix and something amazing happens. The chemical bonds inside luciferin break in just the right way, releasing a tiny flash of energy. But instead of becoming heat or fire, this energy is transformed into cold light, a glow that emits almost no heat at all. This is incredibly important in the deep sea. Generating heat would waste precious energy and could even harm the animal itself in such cold, high-pressure environments. Instead, this elegant process allows for maximum light with minimal waste, creating a soft radiance that is perfectly suited to life in the dark. The colour of this light can vary. Most deep-sea creatures produce blue or green light because these wavelengths travel the farthest in seawater, up to hundreds of meters. Red light, by contrast, fades very quickly in the ocean, which is why red-coloured animals are practically invisible in the deep sea. Some creatures have evolved to glow red for exactly that reason, to be seen only by those who share that secret language of light. Some animals don't even make their own luciferin and luciferase. Instead, they harvest it from their environment. Certain species obtain luciferin from the food they eat, like shrimp or plankton. Others rely on symbiotic bacteria that live inside their bodies. These bacteria are specialists in glowing. In return for a safe home and nutrients, they provide a steady light source, glowing quietly within their host's light organs. These light-producing organs, called photophores, are like tiny built-in lanterns. They can appear on the head, belly, tail, or even under the eyes of the fish. Some photophores are simple, just little glowing dots, while others are complex structures that can focus, angle, or even blink the light on and off. Some creatures even have shutters made of muscle or pigment that they can move to block or expose the light, almost like eyelids. Imagine a fish with a glowing belly swimming under the shadowy surface. Predators looking up from below would normally see the silhouette of its body, but by matching the light coming from above with the light coming from its photophores, the fish becomes invisible. This is called counter-illumination, a clever use of bioluminescence not to stand out, but to disappear. In other species, the light is used to attract prey. The anglerfish, perhaps the most famous deep-sea example, dangles a glowing lure from its head, waving it gently like bait in front of its mouth. Smaller fish, drawn by curiosity or the promise of food, swim toward the light, only to find themselves trapped in jaws lined with sharp teeth. Others use their light as a way of communication. By blinking in certain patterns, they can identify members of their species or attract a mate. Some may even use their light as a distraction. When threatened, they might flash suddenly to confuse a predator, buying themselves a moment to escape. And then there are creatures like the flashlight fish, who can open and close their light-producing organs like shutters. They use this ability to signal to other fish to light up their surroundings as they swim through coral reefs, or to create strobe-like flashes that disorient their enemies. What makes all of this even more astonishing is how precise and energy efficient it is. Unlike artificial light, which often produces heat and wastes energy, the light of bioluminescence is incredibly efficient, often approaching nearly 100% conversion of chemical energy into light. It is one of the most perfect examples of natural engineering we've ever discovered. Even today, scientists are still learning about the exact mechanisms and variations of bioluminescence. New species are discovered all the time, many of which glow in unexpected ways or use unusual combinations of chemicals. Some even have yet to be understood light-producing systems, showing us that nature still holds many secrets. As we float in the silent dark of the deep sea, surrounded by creatures who carry their own light within them, it's humbling to think that such beauty comes from such delicate, precise chemistry. That a simple reaction between luciferin, luciferase, and oxygen can produce something so gentle, so peaceful, and so profound. In this quiet underwater world, light isn't just something you see. It's something you are. Light to us is everywhere. It wakes us up in the morning, fills our rooms, follows us through some screens, lamps, headlights, and glowing city streets. It's hard to imagine life without it. But in the vast depths of the ocean, where the sun's rays cannot reach, and where darkness is not just a backdrop but the very fabric of existence, light is rare. And because it is rare, it is also precious. Down in the deep sea, light means survival. It's not just something pretty or fascinating. It's a lifeline, a tool, a language, a secret. And the creatures that live in these lightless depths have evolved to use it in ingenious, often breathtaking ways. Each glowing spark, each pulse of illumination serves a specific and powerful purpose. Imagine for a moment drifting through this silent black world, surrounded by miles of cold water and sensing only the occasional flicker in the distance. That flicker might be food, it might be a friend, it might be a warning, it might even be a trap. In the absence of everything else, that small shimmer of light becomes everything. Let's begin with one of the most basic yet critical uses of bioluminescence: finding food. In the deep sea, meals are few and far between. Many animals survive on what's known as marine snow, tiny flakes of dead plankton, fecal matter, and organic dust that drifts slowly down from the sunlit surface. But larger creatures often need more. So some of them use light as a lure. The anglerfish, for example, carries a glowing orb at the end of a long, rod-like extension above its mouth. It waves this light gently in the dark water like a fishing line. Curious prey approach the glow, thinking it might be something edible, until they get too close, and the anglerfish strikes. In this way, bioluminescence becomes a weapon, a gentle light that masks a deadly purpose. Other creatures use light not to attract food, but to catch it more efficiently. Some shrimp and squid have glowing patches under their eyes, which they use to light up small prey in the water, much like a person using a flashlight to search through the dark. It's a quiet, calculated glow, not enough to draw attention from predators, but just enough to see what needs to be seen. And speaking of predators, light also plays a critical role in staying alive. In the absence of sunlight, many deep-sea predators hunt by looking upward, trying to spot the silhouette of prey swimming above them. But some fish have evolved a remarkable countermeasure. They produce light on the underside of their bodies, matching the dim blue light that filters down from above. This technique, known as counter-illumination, helps them blend in with their environment. To a predator looking up, the glowing belly of the fish appears to merge seamlessly with the faint light above, making the fish almost invisible. It's camouflage, not made with colour or pattern, but with light itself. This use of bioluminescence as defensive mimicry doesn't stop there. Some animals can create sudden bursts or flashes of light when threatened, startling their attackers and giving them just enough time to escape. Others, like certain squids, can eject glowing clouds of bioluminescent ink, a bright, distracting flash that lingers in the water, confusing predators while the squid vanishes into the dark. In these ways, light becomes a shield, a decoy, and a getaway vehicle, all rolled into one. But bioluminescence is not only about hiding or hunting. In some parts of the deep sea, light is also used to communicate. Some fish and shrimp flash in rhythmic patterns to signal to others of their kind. These glowing pulses can mean many things. I'm here, this is my territory, stay away or come closer. In a world without sound, without colour, without scent trails or tracks in the sand, communication must happen in a language made of light. This is especially important when it comes to finding a mate. In the vast emptiness of the deep sea, finding another of your kind is no easy task. Some animals solve this problem by using unique glowing patterns, like a signature written in light. Only those who share the same biological code will recognize and respond to the signal. In this way, light becomes a beacon of connection, a glowing invitation in the dark. Even tiny plankton use bioluminescence in meaningful ways. When disturbed by a predator, a passing boat, or even a human swimmer, they light up in a defensive burst. These flashes can draw the attention of larger predators, who then target the threat. It's as if the plankton are calling for help, signalling, "Something is bothering me, come deal with it." This form of indirect defense is remarkably clever, and it shows how even the simplest of organisms can use light to their advantage. Beyond the practical uses of food, defense, and communication, light in the deep sea may also serve purposes we don't yet fully understand. Some creatures glow continuously without an obvious reason. Is it a form of internal rhythm? A way of keeping time in a place with no day or night? Is it a vestige of evolutionary history? Or something more subtle, more intimate? Perhaps even a form of self-awareness, of presence in the void? These are the questions that still linger as we study the deep. What we do know is that bioluminescence is incredibly widespread. It has evolved independently in dozens of unrelated species. It exists not just in fish, but in jellyfish, squid, crustaceans, bacteria, worms, and even some sharks. This suggests that the advantages of glowing in the dark are so powerful, nature has reinvented it over and over again, in different ways, in different lineages, across millions of years. It is one of the great convergences in evolution, like flight or eyes or intelligence. Light, it seems, is too valuable to ignore, and perhaps that's the most poetic part of it all. In the darkest parts of our planet, where pressure is crushing and light is gone, life still chooses to shine, not because it is easy, but because it is necessary. Light becomes a whisper of existence, a message sent out into the abyss saying, I am here, I am alive, I endure. So the next time you see a glowing jellyfish, or a photo of a deep-sea fish with tiny lanterns glowing from its sides, remember that light is not just beautiful, it is the result of millions of years of survival, adaptation, and quiet resilience. In the deep ocean, light is life, soft, flickering, and essential. In the deep, dark waters of the ocean, where light is a rare treasure and danger lurks silently in every direction, some of the most fascinating adaptations in nature have evolved. Among them is a truly counterintuitive idea, using light not to stand out, but to vanish. It sounds impossible. How can something that glows help an animal hide? And yet, in the world of deep-sea survival, this tactic is not only possible, it's common. It's called counter-illumination, and it may be one of the most brilliant forms of camouflage nature has ever devised. To understand counter-illumination, imagine you're a predator swimming through the inky blackness of the ocean's midnight zone. The only way to spot your prey is to look up. You're hoping to catch the outline of something swimming above you, silhouetted against the faint, scattered traces of sunlight that still barely filter down from the surface. That's right. Even in the deep sea, a tiny trace of blue light from above can be seen. It's not bright. It's barely there, but it's enough to create contrast. If a fish passes above you and its belly is dark, you'll see it, just a shadow gliding through the dim water. That shadow could mean food. And in the deep sea, where meals are few and far between, predators have evolved to scan for even the faintest silhouettes. This is the problem that some prey animals have solved, not by becoming transparent, not by hiding behind rocks, there aren't many down here, but by producing their own light. It's a genius move. These fish and squid and shrimp grow specialized light-producing organs called photophores on the underside of their bodies. These organs don't glow randomly. They produce light that matches the exact intensity and color of the faint light coming from above. In doing so, the animal erases its own shadow. To a predator looking up, it seems to disappear. It's not that the animal becomes invisible, it's that it stops creating a contrast against the background. It blends perfectly with the overhead glow, not with pigment or pattern, but with active light. The precision of this camouflage is astonishing. These animals can adjust the brightness of their glow depending on how much ambient light is around them. If a cloud passes overhead or a wave changes the surface brightness, the fish's photophores can dim or brighten accordingly in real time. It's like a living dimmer switch, a responsive cloak made not of fabric but of photons, and the equipment is delicate, beautiful, and complex. In some species, photophores are arranged in intricate symmetrical patterns. They may look like rows of tiny dots, but behind each one is a miniature light-producing machine. Some have lenses and reflectors, like a flashlight. Some can be covered with flaps of skin to shut off the light. Others use filters to shift the colour slightly, so that the glow matches the surrounding light perfectly. This is not random evolution. This is surgical adaptation, honed by millions of years of pressure to survive. And it's not just fish that use counter-illumination. Certain squids and crustaceans do it too. Even some species of sharks, like the velvet belly lantern shark, have photophores on their bellies. Despite their slightly larger size, they can still use this same trick, erasing their presence from below by blending with the faint glimmer from above. It's important to note that counter-illumination is only possible because of the unique light dynamics of the ocean. Water absorbs light quickly, especially the red, orange, and yellow wavelengths. Blue-green light travels farthest, and that's the colour most animals use for their bioluminescence. It's also the colour that dominates the twilight zone of the ocean, the mesopelagic, where counter-illumination is most effective. Above that zone, there's enough sunlight to see normally, Below it, there's no light at all, so glowing might only reveal your position. But in this delicate middle region, where some light remains but shadows still exist, counter-illumination becomes the perfect defense. The balance must be just right. There's something deeply elegant about this strategy. It's not aggressive, it's not noisy, it's not flashy, it's subtle, it's patient. The animal simply disappears, not by running, not by fighting, but by learning how to be unseen. And in a way, it reflects a deep truth about nature, that survival often comes not from overpowering your environment, but from learning how to become a part of it. This kind of light camouflage isn't something we see on land. Animals here use colour, texture, and behaviour to blend in, but none of them generate light to erase their shadow. The sea is the only place where this miracle occurs, and it happens in silence every day, thousands of meters below our feet. The fish and squid using counter-illumination don't know that we find their abilities amazing. They simply live this way, blinking gently, adjusting their glow, drifting through the deep like living stars, hidden but not hiding, glowing but unseen. There's a calm beauty in that, a quiet genius, and perhaps as we reflect on their ability to master both light and dark, we're reminded that sometimes the greatest strength lies not in standing out, but in perfectly knowing when and how to disappear. In the mysterious quiet of the deep sea, where light is both a rarity and a precious tool, some creatures have turned the art of deception into something strangely beautiful. Among the most iconic of these is the anglerfish, bizarre and haunting figure from the darkness, a creature that has become a symbol of deep-sea life. But it is far more than just a scary-looking fish with a glowing bulb. It is the master of a deadly trick, using light as a lure. Picture it, a lonely fish, suspended in the silent water, hundreds or even thousands of meters below the surface. Around it, only blackness, no moon, no sun, no sound, just balance. And then a faint glow hanging in the water, like a ghostly orb. That light comes not from above, but from the anglerfish itself. On its head is a long, thin extension of its dorsal fin, almost like a fishing rod, and at the end of this flexible spine is a glowing tip. It sways gently in the water, moving slowly, rhythmically, like a worm on a hook. This luminous appendage is called an esker, and it contains bioluminescent bacteria, microscopic light makers that live inside the anglerfish in a perfectly balanced relationship. The anglerfish doesn't produce this light on its own. It hosts these bacteria in a special organ at the end of its lure, feeding them and sheltering them, and in return they glow, a cold blue-green shimmer that pierces the eternal black of the deep. This glow is not accidental, it's not random. The anglerfish uses it, it manipulates it. It knows that in a world of darkness, any flicker of light becomes a signal, a promise, a mystery, a temptation. Small fish, shrimp, and squid wandering the deep see this soft glow and are drawn to it. Maybe it looks like prey. Maybe it just breaks the monotony of the dark. But whatever it is, it draws them in, closer, closer, until the anglerfish opens its enormous mouth, and in an instant the glow becomes the last thing its prey ever sees. The mouth of the anglerfish is wide and filled with long, inward-curving teeth, designed not to tear but to trap. Once something enters that yawning maw, it can't escape. The anglerfish doesn't even have to chase, it simply waits. It is the stillness of death, wrapped in the gentle glow of light. This hunting strategy, passive, patient, eerie, works extraordinarily well in the deep sea, where chasing prey would be wasteful. Down here, food is rare, energy is precious, every movement counts. So instead of expending energy in pursuit, the anglerfish creates a trap, a living illusion made of light. But anglerfish aren't the only ones to use this technique. Many other deep-sea creatures have evolved similar glowing lures. Some jellyfish have dangling tentacles that pulse with light to draw prey in. Certain types of dragonfish have chin barbels, long, thread-like structures, tipped with glowing bulbs they can wave back and forth. Some squids even flash their arms with bioluminescent signals, mimicking the movements of small, helpless prey. It's a trick that works across species, across forms, across millions of years of evolution. Light is a universal attractor, a lure in the darkness, a question that demands to be answered. What is that? Should I go closer? Sometimes the light is steady, like a beacon. Sometimes it flickers like a heartbeat. Sometimes it dances and pulses in strange hypnotic patterns. These patterns can mimic the movement of living creatures, prey animals, schools of fish, or the flicker of disturbed plankton. In the deep sea, vision is limited, and many creatures operate on instinct. If something glows and moves like food, they follow it. This form of mimicry, using bioluminescence to imitate life, is one of the ocean's most effective illusions. What makes it even more remarkable is that this light isn't just used to attract prey. Sometimes it's used to distract it. In certain species of jellyfish, glowing appendages are used to mislead predators, drawing them away from the body. In others, bursts of light are used like flares, momentary distractions that allow the glowing creature to escape. But when it comes to pure intentional deception, the anglerfish still reigns supreme. Its entire anatomy is built around this strategy. The lure, the oversized mouth, the expandable stomach that allows it to eat prey almost as large as itself. It is a predator sculpted by stillness and strategy. And within the anglerfish family, there is even more complexity. In some species, it is only the females who grow large and develop the glowing lure. The males are tiny, sometimes just a fraction of the female's size, and thus they have a very different mission: to find a mate in the dark. When a male finds a female, he bites onto her skin and eventually fuses with her, becoming little more than an attached body that supplies sperm when needed. It is one of the strangest reproductive strategies in the animal kingdom, and it all unfolds under the quiet glow of that single swaying light. There is something oddly poetic about this image. A giant female anglerfish, drifting through black water, her glowing lure lighting a tiny circle of space in front of her. Attached to her side is her mate, barely visible. Around her, darkness, stillness, the endless silent deep. That one little light, that glowing question in the dark, is her way of surviving, of feeding, of existing. It is, in every sense, her lifeline. And so, in the deepest parts of the ocean, light becomes not just a beacon of beauty, but a trap, a trick, a whisper that says, "Come closer," when what waits is anything but friendly. This is the paradox of light in the deep. It can reveal, but it can also deceive. It can protect, but it can also destroy. And in the hands, or fins, of creatures like the anglerfish, it becomes a deadly dance between wonder and danger. The ocean, after all, is not just a place of peace and mystery. It is also a place of survival, shaped by patience, darkness, and evolution's endless creativity. And in this silent war of light against dark, the glowing lure is both a weapon and a warning. In the quiet, shadowed world of the deep sea, where darkness stretches in every direction and the pressure is immense, life finds its own secret rhythms. It breathes, pulses, drifts, slowly, gently, in a space untouched by sunlight and unknown to most of humanity. And yet, even here, beneath thousands of meters of water, there exists something so deeply familiar, so surprisingly human, that it might just take your breath away. the soft glow of a creature searching for love. Yes, even in the deepest trenches of the ocean, far below the crashing waves and golden reefs, animals search for partners, for connection, for the continuation of their kind. And they do so not with words or sounds, not with flowers or songs, but with light. Imagine a male and female fish, each no longer than your hand, floating miles apart in total darkness. They cannot see each other unless something draws their attention, and in a world without daylight, that something is often bioluminescence. Here, light becomes a message, a signal of identity. It says, I'm here. It says, I'm like you. It says, come closer. These animals have evolved not just to glow, but to glow in very specific ways, patterns, flashes, and rhythms that are unique to their species, and sometimes even to their sex. To us, it might look like a little blinking light, a soft flicker in the water, but to the fish drifting nearby, it's a clear, unmistakable signature. I am a potential mate. This form of bioluminescent courtship is delicate, refined, and deeply efficient. In an environment where food is scarce, movement is dangerous, and confusion can mean death, animals need to be certain before they approach another. The wrong signal could lead to wasted energy, or worse, to a hungry predator. That's why many deep-sea creatures have evolved species-specific light patterns, just like birds have songs or fireflies have flashes. One type of lanternfish might blink twice, pause, then flash rapidly. Another might glow in a slow, pulsing rhythm. A third might emit a continuous shimmer. Each pattern acts like a biological password, instantly identifying the sender to any observer who shares the same genetic code. And the message isn't just, this is who I am. Sometimes it also says, this is what I want. Some male fish can intensify their glow during mating season. Others position their photophores, the light-producing organs, in places where they become most visible to a searching partner. For example, some species have glowing tails or bellies that shimmer just enough to attract attention from below. It's a quiet performance, a display of readiness, a signal in the silence. There's a kind of intimacy in this method of connection. These creatures are not calling out across great distances. They're whispering with light, and that whisper can be everything. In the still, dark ocean where movement is slow and cautious, a well-timed flash can mean the difference between loneliness and union. Some creatures, like certain deep-sea squid, go even further. They communicate not just through when they glow, but how and where. Their bodies become living displays, glowing in different spots and directions. These glowing displays may not just attract mates. They may tell stories. I am healthy. I am strong. I am ready. And then there's the remarkable case of the ostracods, tiny shrimp-like creatures that create elaborate bioluminescent mating dances. Males release glowing chemicals into the water in precise patterns, creating spirals or trails of light. These glowing trails float and drift in the current, and females watch from a distance, choosing the one that dances best. It's a light show in miniature, courtship written in glowing ink. But even in the realm of fish, light is used as a delicate invitation. Some fish, like the flashlight fish, can open and close their glowing eyes, almost as if winking. They use these controlled flashes not just for hunting and hiding, but for signaling to one another. A soft blink in the dark can be a greeting. A brighter flash can say, "Follow me." A dim pulse might mean, "I'm here, but I'm shy." These displays often involve very little risk. By using light that matches the colour of the surrounding water, usually blue-green, the fish remain nearly invisible to anything that doesn't share the same sensitivity. Many deep-sea predators can't even see red light, which is why some species glow red instead. It's a way of communicating in a private language, like passing notes under the table. In some cases, light is not only used to find a mate, but to stay with them. In certain species of deep-sea anglerfish, for example, the male finds the female by following her glow, but once he reaches her, he doesn't leave. Instead, he bites into her skin and fuses with her body permanently. He becomes a tiny appendage, supplying sperm when needed and feeding off her bloodstream. It's an extreme adaptation to an environment where mates are nearly impossible to find twice. The initial connection is made through the light, and from that light, an unbreakable bond is formed. Of course, not every glowing creature is looking for love. Some use light to communicate within schools or families. Others may flash in response to stress or surprise, but for many, light is intimately tied to reproduction, to attraction, to courtship, and to connection in a world where most creatures live their lives alone. And perhaps that's the most poetic part. In a place defined by this separation, by vast distances and eternal dark, animals still seek each other out. They still strive to connect, and they do so not by shouting, not by rushing, but by gently glowing, by sending out pulses of light into the unknown, hoping that someone somewhere is watching and glowing back. It's a quiet reminder that even in the loneliest corners of the earth, the desire to be seen, to be recognized, and to be joined in something greater than ourselves still shines. And sometimes all it takes is one small spark in the dark, in the vast, inky expanse of the deep sea, where silence reigns and the darkness seems eternal. A strange and intelligent group of creatures glides effortlessly through the water. The squids, agile, mysterious, and surprisingly social, squids are among the most fascinating users of bioluminescence. But while many deep-sea creatures use light for camouflage, hunting, or attraction, certain squids take it one step further. They communicate with it. Imagine being able to speak, not with words or sound, but with patterns of glowing light that ripple across your body. Imagine having a language made entirely of flickers, pulses, and glows, a kind of underwater Morse code where every blink and shimmer holds meaning. This is not science fiction. For many squids, this is real life. Squids possess an extraordinary ability to manipulate their appearance. Even shallow water species like the cuttlefish and reef squid are masters of colour and shape, able to change their skin's tone and texture in milliseconds. But in the deep sea, where colour is useless and darkness is absolute, some squid have evolved bioluminescent organs that they can flash in patterns. These glowing signals act as a silent conversation in the abyss. The bioluminescent organs, often located along the arms, tentacles, body, or beneath the eyes, are highly specialized. They are called photophores, and they work like tiny natural lanterns, each capable of glowing with great precision. Squids can flash them quickly, hold them steady, dim them, or arrange them into blinking patterns, and that they can do this across multiple points of their body at the same time. It's like having dozens of tiny lighthouses under your skin, each capable of signaling in tandem or in sequence. These displays serve many purposes. Some are defensive, flashing to startle predators or create confusion. But others are social, intended for other squids nearby. Scientists have observed squid engaging in what looks like back-and-forth exchanges of light, flashing one pattern and then waiting for a reply. When another squid flashes a similar pattern back, it might be a way of saying, "I'm one of you," or "don't be afraid," or even "follow me." Think of it as a kind of visual language, a form of expression in a place where speaking or hearing is nearly impossible. In the thick sense of the deep sea, where sound doesn't travel well and vision is limited, light becomes the perfect medium. It's fast, is visible from a distance, and it stands out against the endless black. Every flash is a message, every pause a moment of listening. For some squids, these light-based signals may be used during mating rituals. A male squid might flash a particular sequence to a female, a glowing courtship dance precise and timed. If the female responds with a similar glow, she may be expressing interest. If she stays dark, she might be signaling rejection. It's a delicate, silent interaction, respectful, cautious, and entirely lit by natural light. Other times, squids may flash warnings to competitors or rivals. Two squids encountering each other might both light up, not to fight, but to measure one another. In some species, larger or more dominant individuals produce brighter, more complex flashes, possibly as a form of visual intimidation. The goal may not be to start a confrontation, but to avoid one. A conversation of dominance resolved without a sound. There's also the matter of group coordination. Some species of squid travel in schools, moving together in large numbers, especially during migration or feeding, to keep the group synchronized in such darkness. Squids may use bioluminescent pulses to signal changes in direction, alert others to danger or indicate the presence of food. It's like using headlights and turn signals, except underwater, and with bodies that light up from within. And not all squid bioluminescence is internally generated. Some species host symbiotic bacteria in their photophores, much like flashlight fish and anglerfish. These bacteria glow continuously, and the squid can cover or expose them using muscular shutters or reflective tissue. This allows for a range of light displays, from steady glows to blinking patterns, that the squid can use with great control. One especially remarkable example is the firefly squid of the Western Pacific. Though it doesn't live in the deepest parts of the ocean, its bioluminescent abilities are astounding. The firefly squid has rows of photophores along its arms and body, and when it swims in large groups, the ocean seems to glitter like a living constellation. Researchers believe that this dazzling display may help attract mates, confuse predators, and keep the group together. Imagine the sea suddenly lighting up in soft blue flashes, moving and shifting in unison, like stars dancing underwater. What's truly awe-inspiring is how these creatures combine their light displays with other forms of expression. Some squid can still use chromatophores, pigment-filled sacs that expand or contract to change colour, even in the twilight zone. In species that dwell closer to the surface, they may mix bioluminescent flashes with colour shifts, creating a multi-layered language of both light and pigment. To us, it's almost unimaginable. Human language depends on breath, on sound waves travelling through air. But in the ocean's deep silence, light becomes breath. Light becomes language. And just like in our own conversations, context matters. A flashing signal could mean different things depending on the time, the setting, the behaviour of the squid, or who else is present. It's a language not of fixed meanings, but of nuance, of feeling, of attention. Perhaps what is most moving about the squid's glowing communication is that it reminds us of something very familiar. The universal need to connect. Even in a realm of eternal dark, even among species that drift alone through the blackness, there exists the desire to be understood. The need to say, I am here. You're not alone. We belong to the same world. Every light, every shimmer is a message flung bravely into the dark, not knowing who might be watching but glowing anyway. And so as squids pulse and flash in silence, they teach us something profound. That communication doesn't have to be loud. That connection doesn't always need noise. And that sometimes, even in the darkest places, light becomes a voice. In the deep ocean, where sunlight cannot reach and darkness stretches on in every direction, nature has found remarkable ways to adapt. And among the most curious and enchanting adaptations is the flashlight fish, a creature that quite literally carries a flashlight beneath its eyes. At first glance, the flashlight fish may seem small and unassuming, It's a modest, sleek creature, usually just a few inches long, with smooth scales and gentle movements, but hidden just beneath each of its eyes is a pair of glowing organs that shimmer with a soft, steady light, like two tiny lanterns in the dark. These glowing organs are filled with bioluminescent bacteria, microscopic beings that live in harmony with the fish. The bacteria glow on their own, producing light through a chemical reaction involving luciferin and luciferase, just like in other deep-sea organisms. But what makes the flashlight fish so fascinating is not that it glows, but that it can control that glow with incredible precision. The light from the bacterial organs can be turned on and off, but not by switching off the chemical reaction. The bacteria continue to glow constantly. Instead, the flashlight fish has evolved a muscular flap of skin, like a little eyelid that can slide over the light-producing organ. When the fish wants to turn off the light, it simply closes the flap, hiding the glow completely. When it wants to shine again, it opens the flap, revealing the soft light to the world. This seemingly simple mechanism allows the fish to blink, to flash, and to signal with exact timing. It is not just a passive glow, it's a controlled beam, a tool for survival, communication, and exploration in the ocean's darkest corners. But why would a fish need flashlights under its eyes? The reasons are many, and each is more fascinating than the last. First and foremost, the flashlight fish uses its light to navigate and find food in complete darkness. By shining a beam of light in front of itself, the fish can illuminate small prey, such as plankton, tiny crustaceans, and other drifting morsels that would otherwise be invisible. This glow gives the fish a way to see in an environment where eyesight alone would be useless. It's like having headlights in a cave, a soft spotlight that allows the fish to move with confidence. The fish's eyes are uniquely adapted to work in tandem with its lights. Researchers believe that the light doesn't just help the fish spot food, it may also help stimulate or attract prey. Tiny organisms drawn to the glow may wander too close, only to be swiftly snapped up by the waiting predator. But the flashlight fish isn't just hunting, it's also communicating. In some species, these blinking lights are used to signal to other members of the group. In the dark, visual contact is nearly impossible, but by blinking in specific rhythms, flashlight fish can send out simple messages. I'm here, follow me. This way. Schools of flashlight fish have been observed blinking in synchrony, moving together in fluid, coordinated motions through the Black Sea, like a constellation in motion. The blinking can also be used as a defense mechanism. When startled, flashlight fish have been known to create rapid flashes of light, bursts so quick and disorienting that they confuse predators. Imagine a predator closing in on what it thinks is an easy meal, only for the fish to vanish behind a strobe of blinding light. The sudden flash overloads the predator's visual system, and the fish slips away into the safety of darkness. In this way, the light becomes a weapon, not of harm, but of distraction and escape. In some environments, flashlight fish have been observed hiding in crevices and coral formations during the day, only emerging at night to feed and signal. In tropical reefs and coastal areas, where they may live in caves or under ledges, their lights flicker out into the water like lanterns in an old harbour town. Fishermen throughout history have reported seeing glowing shapes beneath the surface, like fireflies under the sea. Many of these sightings are believed to have been flashlight fish. There is something almost otherworldly about the way they move, a group of small glowing creatures blinking silently as they swim, their paths weaving together in the blackness. It feels like a natural choreography, a quiet dance of light and life that takes place every night, hidden from most human eyes. Interestingly, some species of flashlight fish are found in shallow tropical waters, unlike many other bioluminescent creatures that live at extreme depths. This has made them more accessible for study and even led to their presence in some public aquariums. But even in captivity, they retain their mystery. When the lights dim, their eyes begin to flicker, and the shadows come alive with soft, blinking glows. What sets the flashlight fish apart is not just the light itself, but its relationship with the light. It is not a passive glow like the jellyfish drifting with their shimmering bells. It is not a stationary lure like the anglerfish's deadly lantern. It is a tool, used actively, intelligently, precisely. It is as if the fish has learned to wield darkness and light, moving between them with a quiet mastery. This ability to both see and be seen, to reveal and hide, gives the flashlight fish a kind of fluid identity in the ocean's theatre. One moment it is a shadow, the next a signal, a predator, a friend, a flare in the dark, a vanishing spark. And perhaps that is what makes this creature so mesmerizing. In the vast, quiet sea, where every flicker of light carries meaning, the flashlight fish reminds us that even the smallest living beings can command the darkness, not by banishing it, but by embracing it and shining through it, one blink at a time. Deep within the ocean, in the still blackness where sunlight never dares to reach, many of the creatures that glow do so with a little help, not from their own cells, but from some of the smallest life forms on Earth, bioluminescent bacteria. These microscopic organisms are the hidden architects behind some of the ocean's most enchanting light shows, and their relationships with larger sea creatures reveal one of nature's most intimate partnerships, a mutual exchange between the unseen and the seen, the tiny and the vast. You see, not all bioluminescent animals produce their own light. While some generate it internally through chemical reactions in their cells, others rely entirely on symbiosis, the ancient biological arrangement where two different species live together in close, often permanent relationships. In the case of glowing sea creatures, this partnership is quite literally a matter of hosting light. Imagine a fish drifting silently through the black waters of the deep sea. Instead of producing light on its own, it carries millions, even billions, of glowing bacteria inside specially adapted organs called light organs or photophores. These organs are designed to house, nourish, and regulate the bacterial colonies. In return, the bacteria produce a constant soft glow that the host animal can use for hunting, hiding, or communication. This relationship is an elegant balance of needs. The fish or squid provides the bacteria with a stable home, consistent temperature, nutrients, and protection from predators. In the cold, nutrient-scarce depths of the ocean, this is no small favour. In turn, the bacteria produce light without needing prompting. They simply glow day and night, their collective shine combining into a visible, powerful effect. One of the most famous examples of this partnership is the Hawaiian bobtail squid, a small nocturnal creature that lives in shallow coastal waters. By day, the bobtail squid hides in the sand, but by night, it emerges to hunt, and it does so with a built-in stealth system powered by bioluminescent bacteria. Inside its mantle, the squid houses a dense colony of Vibrio fischeri, a species of glowing bacteria. These bacteria live in a specialized light organ and produce a bluish-green glow that the squid can adjust and direct. But here's where the magic happens. The squid uses the glow to perform counter-illumination, shining light downward to match the brightness of the moonlight or starlight filtering through the water. To predators swimming below, the squid silhouette disappears against the light from above. Without the bacterial glow, the squid would cast a shadow and risk being spotted. But with it, it becomes invisible, not by hiding, but by blending into the light itself. The squid's relationship with its bacteria is also remarkably selective and dynamic. When it hatches from its egg, the squid doesn't have any bacteria yet. It must gather them from the ocean. But not just any bacteria will do. The squid is specifically tuned to recognize Vibrio fischeri As water flows through its body, the squid filters and selects only that species, guiding it to its light organ while rejecting all others. Once the bacteria arrive, a transformation begins. The squid's tissues change, blood vessels grow, the organ matures, all triggered by the presence of its glowing guests. This is a developmental partnership, a kind of biological handshake where both sides grow and change in response to the other. Interestingly, each morning the bobtail squid expels most of its bacterial colony, releasing 90 to 95% of its glowing passengers into the ocean. Scientists believe this may help regulate the colony's size and health, while also possibly seeding the surrounding waters with fresh bacteria for the next generation of squids. By nightfall, the bacteria have multiplied again inside the squid, ready to shine once more. It is a daily rhythm of release and regrowth, a cycle of light born from trust and balance. This kind of symbiosis is not unique to squids. Certain deep-sea anglerfish also rely on glowing bacteria to light up the dangling lures that hang from their heads. These lures don't produce light on their own. Instead, they are home to colonies of symbiotic bacteria, which produce a consistent glow that helps attract prey. Anglerfish too must recruit these bacteria from the surrounding water early in life, but scientists still don't fully understand how the fish and bacteria find each other in the vast ocean. What we do know is that once the bacteria are in place, the anglerfish develops control over the light. With muscular flaps, reflectors, or lenses that can intensify, dim, or focus the glow, the bacteria shine constantly, but the fish determines when and how that light is seen. The benefits to the bacteria are equally compelling. Living inside a fish or squid offers safety and nourishment, a controlled environment free from many of the dangers of open water. In return, their host gives them the opportunity to shine in the spotlight, quite literally. Their glow becomes part of a larger strategy, one that affects the behavior and survival of animals hundreds or thousands of times their size. This microscopic partnership has even influenced human understanding of biology. Scientists studying Vibrio fischeri and its relationship with squid have uncovered insights into how microbes communicate, colonize, and affect their host's biology. These discoveries go far beyond marine life. They've helped us understand the human microbiome, disease, and the nature of host-symbiont relationships across the animal kingdom. There's also a philosophical beauty in this arrangement, a reminder that in nature, even the smallest beings can have enormous influence. A colony of bacteria, too small to see with the naked eye, can light the way for a fish navigating miles of open ocean. They can offer safety, stealth, and strategy in an otherwise perilous world. And in return, the fish carries them gently, feeds them, and gives them a place to thrive. It is a silent cooperation built on mutual benefit and trust. A glowing contract in the dark. So the next time you imagine a glowing fish drifting through the deep sea, remember that light might not come from the fish itself. It might come from an entire community of invisible allies, tiny lives lighting the way, floating in harmony, whispering their presence in flickers and glows. Together, they remind us that even in the deepest, darkest parts of the world, connection creates light. In the deep sea, where darkness presses in from all sides and visibility is measured in inches rather than feet, being seen can be a matter of life and death. Every flicker of light, every glimmer, every glow is noticed. So when a creature suddenly flashes bright in the pitch black and then disappears, it's not just a spectacle, it's a survival tactic, a carefully evolved illusion, a trick played on the senses of the deep. This is the subtle but powerful use of bioluminescence as a defensive weapon, not to attack, not to wound, but to confuse, to disorient, to distract. In the eternal night of the deep ocean, some creatures use light as a kind of underwater smoke bomb, flashing a sudden glow that shocks a predator and gives the prey a crucial few seconds to escape. It's a strategy that is silent, harmless, but remarkably effective. Imagine a small deep-sea shrimp, no bigger than your thumb, floating in the cold blackness. A shadow looms nearby. A predator, perhaps a squid or a hungry fish, moving with deliberate quiet. The shrimp senses danger. It doesn't have speed on its side, it doesn't have armor, but it does have a secret. With a sudden motion, the shrimp releases a cloud of glowing blue bioluminescent chemicals into the water, almost like a glowing ink. The cloud expands and pulses, lighting up the dark in a burst of eerie brilliance. The predator is startled. It halts, confused, trying to understand what just happened. Did its prey explode, multiply, vanish? By the time it makes sense of the glow, the shrimp is gone. This behavior is known as a bioluminescent distraction display, and it's one of the most dramatic uses of defensive light in the animal kingdom. Some squid do it by releasing glowing mucus or glowing ink. Others flash their entire bodies for a brief instant, blinding their attackers' sensitive eyes before darting away into the shadows. Even tiny plankton, barely visible to the human eye, use this tactic. When disturbed by the movement of a fish, a hand, or a predator's touch, they emit a sudden, sharp glow. These flashes serve not just to startle, but to call for help. The light may attract the attention of an even larger predator, one that might attack the attacker. It's like shouting help in the language of light. This kind of glowing alert is known as a burglar alarm strategy. The plankton, unable to fight or flee quickly, sends out a glowing signal that says, "Something is bothering me, come check it out." It's a risky move, but it works. Predators of predators may appear, scaring off the original threat. In this way, light becomes not just a weapon or a signal, but a tactical bluff. Some jellyfish go even further. When attacked, they don't just glow. They glow in rings, sending waves of bioluminescence outward in pulsating circles. This can confuse the predator about where the jellyfish actually is. The light moves in every direction, drawing attention away from the jellyfish's central body. It's like a magician throwing light in your eyes while escaping out the back door. There are even cases of detachable glowing body parts. Some small deep-sea fish and shrimp can shed a glowing scale or organ, which continues to shine brightly as it drifts away. The predator lunges toward the light, thinking it's captured its meal, only to realize too late that it's holding nothing. Meanwhile, the actual prey has slipped into the surrounding darkness. These defensive uses of light show us something important. In the deep sea, the line between predator and prey is not just about strength or speed. It's about cleverness. It's about knowing how to play with perception, how to use light like misdirection. And these tricks work especially well because of the nature of vision in the deep ocean. Many predators have enormous, highly sensitive eyes, adapted to pick up the faintest glimmer of light in total darkness. These eyes are so attuned to subtle brightness that a sudden flash of bioluminescence can feel overwhelming, like a spotlight to someone who's been sitting in a dark room for hours. This sensitivity becomes a weakness. What helps predators see in the dark also makes them vulnerable to being blinded, even momentarily, but by a well-timed glow. That moment of disorientation is all a prey animal needs. A single second of confusion can mean the difference between life and death. But it's not just about startling or escaping. Sometimes the glow is designed to send a warning. Some species of jellyfish and siphonophores, long chain-like colonial animals, emit a soft glow that signals toxicity. It's a quiet threat. I am not safe to eat. This glowing display acts much like the bright colours of poisonous frogs or insects on land. It is a visual deterrent, a way of saying don't bother. There are even animals that imitate these warning glows without being dangerous themselves, a phenomenon known as Bayesian mimicry. These copycats pretend to be dangerous by displaying the same glowing patterns as genuinely toxic creatures. It's a bluff, a fake warning that can be just convincing enough to keep predators at bay. And what's most fascinating is how these light-based defenses can be fine-tuned to specific threats. Some species alter the intensity or timing of their glow depending on whether they're being approached from above, below, or behind. Some might glow brighter in open water but remain dark near shelter. Others only glow when touched, keeping their secret weapon hidden until the very last moment. All of this tells us something extraordinary, that bioluminescence is not just a passive trait. It's an active strategy, a living decision, built into the body of the animal. It's both armor and art, a subtle, intelligent form of defense that uses beauty as a shield. In a world without sound, where color and texture disappear into darkness, light becomes the most effective way to communicate, to deceive, and to survive. It's not just about being fast or strong or fierce. Sometimes it's about knowing exactly when to shine and when to disappear. So the next time you think of glowing fish, glowing jellies, or pulsing plankton, remember, some of them are not trying to be seen. They're trying to not be caught. And in the oldest, darkest places of our planet, light has become the perfect disguise. In the vast underwater wilderness of the deep sea, where the darkness never lifts and the pressure of the water can crush unprotected bodies with ease, life begins early, often earlier than one might imagine. Even here, far from sunlight and the vibrant chaos of shallow reefs, new life takes form, and for many of the species that call the realm home, glowing begins not in adulthood, but in the very earliest stages of life. Yes, some deep-sea creatures are born with the ability to glow. Bioluminescence, in these cases, is not something they develop over time. It is written into their DNA from the start, just as surely as fins or gills or eyes. To us, this might seem surprising. Why would something so delicate and small need such a complex power so soon? But in the deep sea, where survival is a matter of constant vigilance, light is not a luxury. It is a necessity. Picture a tiny larval fish, no larger than a grain of rice, drifting slowly in the cold black water. It is just days old. It has no parent to protect it, no nest, no cover. It floats alone in the open water column, exposed on all sides to any predator with the eyes to see it. And yet, in the stillness of the abyss, it pulses softly with light. These pulses are not random. Even at this early stage, the young fish may have tiny photophores, miniature light-producing organs, arranged in simple but functional patterns. The patterns are often symmetrical, and as the fish matures, they grow more complex. In some species, these lights are concentrated along the belly, in others, around the head or tail. These lights are not ornamental. They are tools for survival, used in ways that are astonishingly advanced for such a young life form. One of the primary reasons for bioluminescence in larvae and juveniles is camouflage. Even at the smallest sizes, deep-sea animals are targeted by predators. To avoid casting a shadow against the faint overhead light, which might give away their position, these tiny creatures begin practicing counter-illumination, almost from birth. Their glowing bellies mimic the light above, rendering them nearly invisible from below. Is their first and sometimes only defense. Some baby squid and crustaceans are born with bioluminescent ink sacs, or the ability to flash their bodies in response to touch. It's a reflex that activates as soon as they're capable of movement, like an alarm system hardwired from the very beginning. If a curious fish or jellyfish brushes too close, the baby might emit a quick burst of light, a flare, a flash, enough to disorient or frighten away the danger. Even more remarkable is that in some species, bioluminescence may be used by larvae to help them stay close to siblings or members of the same species. In the deep sea, visibility is so poor that staying connected with others is incredibly difficult. A small flash of light can signal location, allowing a scattered group of siblings to remain loosely connected as they drift with the currents. It is an embryonic form of communication, a biological whisper saying, "I'm still here." For species that go through complex metamorphoses, such as lanternfish or hatchet fish, the arrangement of photophores on the body begins to take shape in early developmental stages. Over time, as the animal matures, the lights may become more specialized, changing in number, intensity, or function. But the beginnings of this intricate light map are already in place from the moment of birth. Some jellyfish, too, display glowing behavior from their earliest stages. Even as polyps or planulae, they can emit faint pulses of bioluminescence. This light may help deter tiny predators or play a role in triggering developmental changes. In sea ctenophores, also known as comb jellies, the larvae often shimmer with iridescent waves of light, generated not just through bioluminescence, but also through light refraction in their moving cilia. These optical effects, while beautiful to us, serve important survival purposes in the murky water. What's more, in certain ecosystems, like the mesopelagic and bathypelagic zones, bioluminescence can help juvenile organisms recognize members of their own species in an environment where nearly everything is transparent or camouflaged. A faintly glowing pattern on a juvenile's body might help it avoid being eaten by a larger member of its own species, an adult who, in the darkness, might mistake the youngster for prey. In that way, light becomes a signature, a safety signal, a subtle identifier in a world of shadows. The early development of bioluminescence also has a striking evolutionary logic. In habitats where visual cues are limited, the pressure to adapt rapidly begins almost immediately after birth. Natural selection favours those juveniles that can hide more effectively, signal more clearly, and confuse predators more successfully. And so generation after generation, the ability to glow is passed down earlier and earlier in life, until it is present from the very start. And for some species, bioluminescence isn't just for defense or communication, it may even play a role in navigation and orientation. Some young fish, squid and shrimp migrate vertically each night, rising toward the surface under the safety of darkness to feed. During these journeys, bioluminescence may act as a rudimentary compass, a way of gauging depth or detecting the presence of fellow travellers. The glow becomes a kind of biological GPS, gently guiding them through a dangerous world. Perhaps most astonishing of all is the fact that we are still discovering just how early these light-producing abilities appear. Because deep-sea juveniles are difficult to collect and observe, much of their behaviour is still a mystery. But as technology improves, scientists are finding more and more examples of bioluminescence in embryos, hatchlings, and early-stage larvae. The deep sea, it turns out, teaches its lessons from the very beginning. Light in this realm is not something you earn, 'tis something you're born with. So the next time you imagine the mysterious glow of a deep-sea fish or the sudden flash of a jellyfish in the dark, remember that for many of these creatures, this isn't something they grow into. It's their very first gift. A flickering torch passed down from their ancestors, lighting the way from their first moments of life. In a world without sunrises, where shadows stretch without end, it is light that marks the beginning. Light that guides the first swim. Light that protects, connects, and reveals. Even in infancy, even in fragility, the glow endures. It is life's quiet promise in the darkness. In the ocean's upper twilight zone, just before the complete darkness of the deep sea takes over, something extraordinary can happen. On rare and special nights, as a boat glides through the water or a swimmer's hand brushes the surface, the sea begins to shimmer, not with moonlight or starlight, but with a glow from within, an eerie, almost supernatural light. It's as if the water has come alive with a pulse of its own. Millions of tiny blue sparks swirl and flicker in your wake, following every movement. You're not hallucinating, you're witnessing one of nature's most magical phenomena. the collective glow of bioluminescent plankton, lighting up the ocean in what seems like a silent celebration of life. These tiny organisms, primarily dinoflagellates, a type of single-celled plankton, are among the most widespread and abundant bioluminescent creatures in the sea. While individually they are too small to see with the naked eye, when disturbed in large numbers, they emit bright flashes of blue-green light. And when thousands, millions, or even billions of them are gathered in one place, the effect is breathtaking. The sea itself appears to twinkle. This phenomenon is sometimes referred to as sea sparkle, and under the right conditions, the sparkle turns into a full-blown light show. As waves crash onto the shore, they glow at the edges. As fish dart through the water, they leave glowing trails behind them. A swimming human is outlined in a halo of blue fire, like a constellation in motion. It's like watching the stars fall into the ocean, or like the ocean has decided to become the sky. But what causes these tiny organisms to glow, and why do they do it together? Bioluminescence in dinoflagellates is a defensive response. These microorganisms glow when they are mechanically stimulated, that is, when something touches or disturbs them. A wave, a paddle, a passing fish, even a raindrop. Anything that creates motion in the water causes the plankton to emit a quick flash of light. It's a form of what scientists call a startle display, designed to confuse or deter predators. Imagine a small fish moving in for a bite. As it opens its mouth to swallow the plankton, the water around it lights up. Suddenly, the fish itself is outlined in glowing light, making it visible to larger predators nearby. The glowing plankton have effectively triggered a burglar alarm, exposing their attacker to danger. In this way, light becomes a form of protection. Now scale that moment up by the millions. In areas where plankton are densely concentrated, such as along certain coasts, bays, or upwelling zones rich in nutrients, this defensive glow is triggered on a massive scale. One fish swims by and thousands of plankton light up in response. Another swims by and the pattern spreads. What began as a single flash becomes a rolling wave of light, rippling across the surface of the sea. This effect is especially dramatic when a school of fish or a pod of dolphins moves through a glowing patch of plankton. You can see the outlines of their bodies traced in blue fire. Every turn, every flick of the tail becomes illuminated. Some of the most famous footage of this phenomenon shows dolphins swimming through bioluminescent waters, their movements painting glowing trails like underwater comets. Sailors have reported seeing entire stretches of sea glowing beneath their ships. In some cases, the wake behind a moving boat can appear as a glowing ribbon miles long. Ancient mariners, with no knowledge of microbiology, believed the seas themselves were enchanted, that stars had fallen into the ocean, or that the souls of drowned sailors had returned to light the way. And who could blame them? To this day, even with scientific explanations, encountering bioluminescent plankton in large numbers can feel deeply spiritual. You're surrounded by living light, by tiny creatures reacting to your every move. It's hard not to feel awe. One of the most mysterious versions of this phenomenon is something called the Milky Sea. Unlike the typical sparkling trails of disturbed plankton, a Milky Sea glows continuously, a vast glowing expanse that can stretch for tens or even hundreds of kilometers. From the deck of a ship, it looks as if the entire ocean has turned into a pool of pale, glowing milk. Sailors have described it as sailing through liquid moonlight. Airplane pilots have seen it from the sky, ghostly glowing patches in the middle of the Indian Ocean. Milky Seas are incredibly rare and poorly understood. They may be caused by dense colonies of luminous bacteria rather than plankton. These bacteria can glow continuously, not just in response to disturbance. The glow may be triggered by environmental factors, a combination of temperature, salinity, and ocean currents that cause the bacteria to bloom and float in place. Unlike planktonic displays, which are brief and flickering, milky seas can last for hours or even days, lighting the night with an otherworldly stillness. Whether flickering plankton or glowing bacterial blooms, these glowing waters share something profound. They are made by tiny life forms acting together. Each flash is small, each organism alone is insignificant. But together they create one of the most beautiful and unearthly spectacles on the planet. It is a reminder that even the smallest beings, when acting in concert, can transform the darkness. There is something deeply calming about this knowledge, that in the vast and often terrifying deep, beauty still gathers, that under the right conditions, when the waters are still, when the night is quiet, the sea responds not with violence but with light. People travel across the world to witness this. Some wade into glowing bays in Puerto Rico or the Maldives. Others hike to remote beaches in Japan or Jamaica, hoping to catch the sea's sparkle. And some unexpectedly stumble upon it on a quiet night, far from city lights, when the ocean decides to reveal its secret. And what a secret it is. A dance of light born from fear, from defense, from survival. And yet it creates something peaceful, beautiful, even magical. It's easy to forget how alive the ocean truly is, but when the plankton light up the water in waves of shimmering blue, they remind us not just of the power of nature, but of its grace, of how the tiniest pulses, multiplied across the body of the sea, can create something that touches the soul. They remind us that light, even in the darkest places, is always waiting to be stirred. Deep beneath the surface of the ocean, in a realm where sunlight cannot penetrate, lives a creature whose name stirs both fascination and unease, the vampire squid. Despite its fearsome name, this enigmatic animal is not a monster of the deep, but a gentle scavenger, quietly drifting through the darkness of the oxygen minimum zone. A part of the ocean so depleted of oxygen that very few animals can survive there. And yet, the vampire squid not only survives, it glows. Its name, Vampiroteuthis infernalis, meaning vampire squid from hell, sounds ominous. But this creature is not a predator, nor is it related to true squids or true octopuses. It's a unique survivor, an ancient remnant from a time long before humans ever stood on land. It belongs to its own order of cephalopods and has existed for millions of years, virtually unchanged, a living fossil drifting through a silent twilight world. The vampire squid is about the size of a football, with a soft gelatinous body that helps it conserve energy in the deep sea, where food is scarce. Its colour varies from deep red to black, and its arms are connected by a cloak-like webbing, giving it a distinctly eerie appearance, part squid, part octopus, part shadow. But what truly sets it apart is its mesmerizing use of bioluminescence. Despite its intimidating look, the vampire squid does not hunt large prey. It has no need to chase or fight. Instead, it uses light in subtle, almost poetic ways, not to lure in victims, but to confuse predators and quietly vanish into the dark. Its body is lined with photophores, light-producing organs that glow with a cool bluish light. These photophores are found on the tips of its arms, across its body and around its eyes, which are proportionally among the largest in the animal kingdom, allowing it to see even the faintest light in the deepest shadows. When threatened, the vampire squid doesn't ink like other cephalopods. Ink would be useless in the deep ocean. It would simply disappear into the blackness. Instead, it produces a cloud of glowing mucus, packed with bioluminescent particles that explodes from the tips of its arm filaments. This glowing cloud creates a sudden, blinding distraction in the otherwise pitch-black surroundings, startling and confusing any predator that gets too close. The display is beautiful and strange, a burst of blue stardust blooming in the water. It lingers just long enough to divert attention, while the vampire squid quietly folds its arms, retracts its filaments, and drifts away into the dark, undetected. In the deep sea, where every flash of light draws attention, the ability to appear and vanish with light is the ultimate defense. But this is not the only trick the vampire squid uses. When threatened but not directly attacked, it performs an unusual behavior known as the pineapple posture. It turns its arms inside out, wrapping them around its body, and reveals the spiny tips of its cere-covered arms. Though these spines look dangerous, they're soft and harmless. Their appearance alone is often enough to deter predators who mistake them for something more threatening. During this posture, its photophores continue to glow faintly, adding a surreal, shimmering outline to its strange, closed-off shape. It appears alien, otherworldly, as if it belongs not to the ocean but to a dream. Unlike many bioluminescent creatures that use light to attract mates or communicate with others, the vampire squid lives a mostly solitary life. It does not gather in schools, nor does it perform light shows for partners. Its bioluminescence is almost entirely defensive, a quiet, personal light, used not to reach out but to withdraw. This makes sense given its habitat. The vampire squid lives between 600 and 900 meters deep, in a zone known as the Oxygen Minimum Zone, OMZ. Here, oxygen levels are too low for most animals, but the vampire squid thrives thanks to its extremely low metabolic rate and special hemocyanin-rich blood that binds oxygen more efficiently than that of any other cephalopod. In this harsh, quiet realm, it survives by feeding on marine snow, the endless, slow-falling flakes of organic material that drift down from the surface. Bits of dead plankton, fecal pellets, and other detritus become its food. It uses two long, retractable filaments, unique among cephalopods, to collect this debris, coating it in mucus and bringing it to its mouth. And all the while it glows. Its light is never aggressive, never showy. It's subtle, strategic, and serene. A flicker to startle, a pulse to distract, a shimmer to disappear. This kind of bioluminescence reflects the deeper philosophy of life in the deep sea. A life lived in silence, in slowness, in shadow. In a world where everything must be used wisely and nothing is wasted, even light becomes measured and intentional. The vampire squid, with its ancient body and delicate glow, reminds us that you don't need to shine brightly to survive. You only need to shine wisely. It does not chase. It does not fight. It simply glides, gathering what it needs, evading what it must, and glowing just enough to remain unseen. Its power lies not in domination, but in invisibility, not in strength, but in subtlety. To watch a vampire squid in motion is to witness something dreamlike, a creature from another time floating through the dark, lighting its path not to be followed, but to disappear into the silence. And perhaps, in a world filled with noise and brightness, there is something profoundly peaceful about this, about an animal that has mastered the art of quiet glowing, and in doing so has survived longer than almost anything else in its class. In the deepest places of the ocean, where time itself seems to move more slowly, the vampire squid continues its ancient journey, drifting softly, pulsing gently, and vanishing into the velvet dark with nothing but a shimmer. A reminder that even in the blackest waters, light can be soft and survival can be silent. Far out at sea, beyond the reach of city lights or coastal noise, there are moments when the ocean undergoes a transformation so surreal, so eerily beautiful that even seasoned sailors are left in stunned silence. The sky may be dark and cloudless, the stars hidden by haze, yet the sea itself glows. Not with reflections from above, but with a steady, ghostly radiance that stretches as far as the eye can see. It isn't a flicker or a sparkle. It's an unbroken, luminous sheet of pale light. No waves, no sound, just a vast, glowing expanse. This is not a fantasy nor a myth whispered by sailors after too much time at sea. This is a real and rare natural phenomenon known as the Milky Sea, and it remains one of the least understood wonders of the bioluminescent world. A Milky Sea is not like the shimmering trails of disturbed plankton that many have seen near the shore. It's not the flashing bursts caused by fish or the glow of jellyfish or squid. A Milky Sea is something entirely different. It is vast, it is persistent, it is quiet and still, and it glows not in sparks or pulses, but with a smooth, steady, almost surreal whiteness, as if someone poured liquid moonlight into the ocean. Reports of Milky Seas go back centuries. Sailors from the 19th century described sailing through glowing waters for hours or even days, noting that the sea seemed as white as milk and as luminous as snow. Some reported that the light was so bright they could read by it. Others described the phenomenon as if the ship was sailing through clouds. In each case, the same strange experience was recorded. A wide region of sea glowing without interruption, sometimes stretching over 10,000 square kilometres, an area larger than some countries. But what causes such an immense and consistent glow? Scientists now believe that Milky Seas are caused not by dinoflagellates, the tiny plankton responsible for most near-shore bioluminescence, but by bioluminescent bacteria, specifically a type called Vibrio harvei and similar species. Unlike the short-lived flashes of dinoflagellates, these bacteria emit a continuous glow, and in Milky Sea events, they exist not just in patches or plumes, but in vast coordinated colonies. What's truly remarkable is how these bacteria coordinate their glow. They use a chemical communication system called quorum sensing. Essentially, each bacterium emits a signalling molecule into the surrounding water. As the population grows, these molecules build up. When the concentration of signalling molecules reaches a certain threshold, indicating that a large enough number of bacteria are present, they all begin to glow in unison. It's like a silent agreement among billions of bacteria. When enough of us are here, we shine together. But even with this understanding, many mysteries remain. Why do these colonies grow to such massive sizes? Why do they persist for hours or days in exactly the same region of open ocean? How do they remain suspended near the surface instead of dispersing? These are questions that continue to puzzle marine scientists. Only in recent decades has modern satellite technology given us clearer evidence of these elusive events. In 2005, a group of scientists used satellite imagery to confirm a massive Milky Sea in the Indian Ocean, off the coast of Somalia. The glow had been reported by a merchant vessel, and the satellite data revealed a glowing patch of ocean over 15,000 square kilometres, about the size of Connecticut. The glowing region persisted for 3 nights. It wasn't affected by waves or weather, it simply glowed. It's difficult to describe the experience of seeing a Milky Sea firsthand, but those who have witnessed it often describe a feeling of stepping into a dream. The glow is not sharp or dramatic, it's diffed, pervasive and haunting. It lacks the blue sparkle of dinoflagellate blooms. Instead, it casts the water in a pale, ghostly white. Boats leave dark trails in the glowing sea like ink being drawn across parchment. Fish appear as shadows outlined in light, and the sky above seems even darker by contrast. Unlike most other forms of bioluminescence, the Milky Sea doesn't respond to touch or movement. There's no burst of light when you dip your hand in. It doesn't flash when a wave crashes. It simply glows, silently and evenly, as if the entire ocean has become a single breathing organism. There are legends, of course. Sailors in earlier centuries told stories of ghost ships, of lost souls lighting the sea. Some believed they were sailing through phosphorescent fog that had fallen from the sky. Others took it as a sign from the heavens, an omen, an otherworldly message. And in truth, even today, there is something deeply spiritual about a Milky Sea. something that transcends science and touches the ancient part of us that longs to believe in mystery. But perhaps the most poetic part of a milky sea is this: it's made of life. Not magic, not illusion, not something from a dream, but billions upon billions of living organisms, each too small to see, glowing together in perfect harmony. Each bacterium emits just a tiny bit of light. Alone it would be invisible, but together, when their signals align and their glow merges, they transform the sea itself into a light source. It is a gentle reminder that even the smallest forms of life can create something vast and unforgettable when they act together. And maybe that's why a milky sea feels so emotional, so stirring, so quietly powerful. It is light born not from power, but from unity, from patience, from the slow, silent gathering of microscopic lives that decide, without a voice, to shine as one. In the darkness of the open ocean, where no lamplight or lighthouse reaches, these living lights illuminate the world in a way nothing else can. They don't flash for attention. They don't demand to be seen. So they simply glow. And in doing so, they remind us that beauty is often found not in spectacle, but in stillness. And if you're lucky enough to witness a milky sea, you might find yourself looking out over that glowing water and feeling something deep in your chest. A kind of peace, a kind of wonder, as if the earth itself were breathing light into the night. It is perhaps one of the ocean's rarest and most sacred gifts, a living miracle, drifting silently beneath the stars. Long before satellites, long before oceanographers, even before compasses and maps, humans set out onto the sea with little more than instinct and courage. These early mariners faced an endless, unknowable world, a shifting horizon of wind and salt and stars, and in the midst of all this mystery, they encountered something that would become etched into our collective memory: the strange, inexplicable glow of the ocean. To the eyes of ancient sailors, bioluminescence must have seemed like pure magic. Imagine drifting in a wooden vessel, far from land, under a black satin sky, only to look over the edge and see the sea glowing, flickering, swirling as if lit from within, as if some unseen force was swimming just beneath the surface. It would be easy, almost inevitable, to imagine supernatural causes. Some believe the glowing waters were inhabited by spirits, souls of drowned sailors, or sea gods rising from the depths to watch over passing ships. Others thought the light came from lost stars that had fallen into the sea, trapped in the waves. The phenomenon was so alien to their understanding of nature that it had to come from something beyond nature, something divine or dangerous or both. In Norse legends, sailors told of glowing sea serpents whose eyes lit up the waves. In ancient Greece, there were tales of Poseidon's chariot stirring up glowing foam as it cut through the water. In Japan, the bioluminescent glow of squid and jellyfish was tied to stories of water spirits and umibozu, mysterious sea monks who rose from the depths, glowing with an eerie light. In the centuries that followed, sailors continued to report encounters with glowing oceans. Some thought the lights were warnings, omens of coming storms or lost souls. Others took comfort in them, believing the lights were a sign they were not alone, that someone was watching and guiding them. When bioluminescent creatures swirled in the ship's wake, some believed it was the trail of mermaids or sea angels. When glowing plankton clung to nets, some thought they were stars pulled from the heavens, caught by accident and woven into the ropes. These stories weren't just superstition, they were poetry, born from the need to understand a natural world that still held so many secrets. Even Christopher Columbus, on his first voyage across the Atlantic in 1492, recorded strange lights in the distance. In his logbook, he described seeing a faint flicker of glow on the horizon, not from land, but from the sea itself. Some historians believe he may have witnessed a patch of bioluminescent plankton, or even the edge of a milky sea. Later, in the 17th and 18th centuries, when the age of exploration expanded and ships roamed farther across the globe, reports of glowing waters became more common. Sailors recorded them in ship logs, noting areas of ocean where the water lit up with every movement, where schools of fish left glowing trails, and where the bow of the ship cut through light like a sword. These glowing seas were seen not just as curiosities, but as omens. In some traditions, a glowing wake was interpreted as a good sign, a blessing for the voyage. In others, it was a warning, especially if it appeared before a storm. The unpredictable nature of bioluminescence only fed the mystery. It wasn't always there. It came and went. It flared up and vanished. And because it couldn't be measured or predicted, it remained firmly in the realm of myth. Even the behaviour of bioluminescent creatures added to the mystique. Fish that glowed when caught in nets, jellyfish that pulsed with light when touched, and strange flashes in the water when nothing visible moved. All of it seemed to defy explanation. How could the sea create its own light? What power lay beneath the waves? For a long time, even natural philosophers and scientists struggled to explain bioluminescence. Some thought it was a kind of chemical heat. Others believed it came from static electricity or friction in the waves. It wasn't until the 19th and 20th centuries that researchers began to isolate the molecules and enzymes responsible, luciferin, luciferase, and the delicate chemical reactions that create cold light. But by then, the stories had already taken root. In many coastal cultures, bioluminescence became woven into ritual and tradition. Fishermen in parts of Southeast Asia would follow glowing waters at night to locate schools of fish. In the Caribbean, glowing bays became sacred, places where the water came alive, where one could wade into mystery and walk through stars. Even today, in places like Vieques, Puerto Rico, people gather to kayak or swim in these magical bays, speaking in hushed tones, moved not just by beauty, but by a deep, almost reverent awe. Tourists marvel at the lights, children squeal with delight as their splashes ignite glowing trails, but underneath the joy is something older, something ancestral, the same wonder that moved sailors centuries ago, the same sense that the ocean is more than water and salt and life, that it holds within it a kind of soul. And in the glow of bioluminescence we glimpse that soul. We see the ocean expressing itself not with thunder or waves, but with quiet light. In literature, the glowing sea appears again and again. From Melville's descriptions of luminous waves in Moby Dick to modern ocean documentaries, the imagery of light in the darkness never loses its power. It stands for mystery, for the unknown, for hope, for guidance. In religious and spiritual metaphors, it becomes a symbol of inner light, of divine presence in the hidden depths. Even now, in our age of science and data, the glowing ocean holds its enchantment. We know the biology. We understand the chemistry. We can measure the light output in lumens. But none of that takes away the magic, because when you're standing on the edge of a glowing sea, when your hand cuts through water that flashes with every movement, when your footsteps leave trails of blue behind you, you feel something ancient, something beyond language. You feel connected not just to nature, but to the countless people before you who saw the same glow and whispered stories into the night. And in that connection, the light becomes something more than biology. It becomes myth. It becomes memory. It becomes a conversation with the deep. A message from the ocean carried across centuries. I am alive. I am ancient. And I still shine in the dark. Far beneath the crashing waves and beyond the reach of sunlight, there exists a kind of beauty that few people ever witness with their own eyes. The gentle, rhythmic glow of bioluminescent creatures pulsing through the dark. There are no storms here, no shouting winds or thundering surf, just silence, just water, just the slow, almost meditative drifting of life. In this quiet world, light is not something loud or harsh. It is not blinding or brash like the flicker of neon or the glare of headlights. It is soft, deliberate, and deeply soothing. It emerges from the bodies of living organisms, not to dazzle or demand attention, but to whisper. The kind of light that feels like a breath in the dark, a heartbeat of the deep. And for us, creatures who live in a world filled with constant stimulation, relentless noise, and flickering screens, there is something profoundly comforting about this kind of glow. To witness bioluminescence is to step outside of time. Everything slows down. Every blink of light, every shimmer in the water feels like a pause, an invitation to breathe. In a world where everything seems to rush, the deep ocean teaches us that light doesn't have to be fast to be powerful. It can move like a wave. It can flicker like a memory. It can pulse like the rhythm of thought. It's no wonder that so many people feel a strange peace when they witness bioluminescence. It's not just the visual beauty, though that is undeniable. It's the emotional resonance. The sense that this glow is speaking to something quiet inside of us, something ancient, something that remembers what it means to be still. When we watch a glowing jellyfish drift through the water, we're not just observing biology. We're watching a kind of living lantern, a spirit of the sea, floating with effortless grace, glowing from within. Its light doesn't beg to be seen, it simply is, and that is its power. Even small organisms like bioluminescent plankton create a collective glow that feels more like a lullaby than a display. When you move through glowing waters, whether swimming, paddling, or simply letting your fingers trail behind a boat, the lights that follow your motion don't startle. They soothe. They react with grace, illuminating not only your path but your presence. You're seen, not as an intruder but as a part of the story. There's something inherently gentle about this kind of interaction. The sea doesn't fight back, it doesn't resist. It greets your touch with light. Many people who have witnessed bioluminescent seas describe it as a spiritual experience, not in the religious sense, but in the way that it makes them feel more connected to something larger than themselves. The ocean in that moment becomes more than water. It becomes a mirror, a space of reflection, a moment of grace, and the light, that quiet pulsing glow, seems to come not just from the organisms, but from the ocean itself, as if the sea were dreaming and in its sleep letting out little sighs of light. This perception of bioluminescent light as soothing is more than metaphor. It connects deeply with the way our minds and bodies respond to gentle illumination. Unlike harsh white light, which can trigger alertness, tension, and even stress, the cool, soft blue-green of most bioluminescent light activates the parasympathetic nervous system, the part of us that governs relaxation, calm, and healing. In this sense, bioluminescence is not just beautiful, it is physiologically calming. It's why staring at the stars can slow your breathing. It's why the glow of fireflies feels nostalgic. And it's why the ocean's glow, gentle, cool, ancient, feels like a balm for the soul. This kind of light does not chase darkness away. It lives within it. It coexists. It respects the dark. It doesn't try to eliminate it. It simply shines within it, softly, persistently, gracefully. There's a lesson in that, one that many of us don't realize we need. In our world, we are constantly told to push harder, shine brighter, stand out more. But the creatures of the deep sea show us a different path. They glow, not to dominate, but to survive, to connect, to confuse, to love, to hide, to thrive. Their glow is purposeful, not performative. They are not seeking applause, they are seeking balance. And that is perhaps the most soothing message of all, that we too can exist in darkness without being lost in it, that we can hold a little light within ourselves, not to blind others, but to see our way through, that even when everything around us feels heavy, uncertain, or quiet, we can pulse softly, we can keep glowing. Bioluminescence reminds us that light doesn't have to be loud to be real, that softness is not weakness, that silence is not absence, and that peace, true, deep peace, often glows in the places we least expect to find it. So the next time you imagine the deep sea, try not to think only of pressure and cold and darkness. Think of the light, the slow, patient, living light that fills that space. The kind of light that doesn't call out to be seen, but calls you inward. And when you close your eyes tonight, if the world feels too loud or too fast, picture a single glowing jellyfish, floating alone in the Black Sea, pulsing slowly, calmly, steadily, lighting nothing but its own body, its own path, its own breath. Then remember, that too is enough. That too is beauty. That too is light. In the delicate, slow-motion world of the deep sea, where the darkness is eternal and every flicker of light carries meaning, there exists a remarkable sense of balance. Every glowing creature, from the tiniest plankton to the most elusive jellyfish, plays a part in a finely tuned ecological system. These flashes and pulses of light are not just beautiful or mysterious, they are integral to the way life in the deep ocean functions and survives. Bioluminescence is not a random trait, nor is it evenly distributed across species. It is a tool evolved in different forms and for different purposes by different animals. And when we look closely at the role of bioluminescence in the deep-sea food web, we begin to see something truly remarkable. Light as language, light as strategy, light as structure. Every flash, every glow, every shimmering burst has a place in the rhythm of the ocean. It's as if the deep sea is conducting a slow, silent symphony, and the lights of the notes, not chaotic but precise, not accidental but meaningful. At the most basic level, this glowing web begins with the producers of light, microscopic plankton and bacteria. These organisms don't glow for entertainment, they glow for survival. Dinoflagellates, for example, emit brief flashes when physically disturbed. This is a defense mechanism meant to startle predators or attract larger ones who might prey on the attacker. The very act of glowing becomes a signal, a warning, a cry for help, or a bluff. These flashes ripple through the water, influencing the behavior of animals much larger than the plankton themselves. In this way, even the tiniest organisms shape the choices of fish, shrimp, squid, and other predators. Their mere light causes predators to hesitate, to flee, to change direction. It affects feeding patterns. It alters the outcome of the hunt. In the middle of this chain are the predators that use bioluminescence to hunt, creatures like anglerfish, dragonfish, and flashlight fish. These animals use light like a trap. Some dangle glowing lures in front of their mouths. Others shine light to spot prey in the dark. Some use bioluminescent patterns to disguise their movements, to mimic harmless animals, or even to confuse their prey into paralysis. Here, light becomes a weapon, but a gentle one. It doesn't kill, but it manipulates. It deceives. It allows predators to strike with minimal effort, conserving precious energy in an environment where food is scarce. Then there are the defenders, animals that glow to avoid being seen or to escape being eaten. Some use counter-illumination, matching the light from above to erase their shadows from below. Others emit sudden flashes to startle predators. Some release glowing clouds like underwater flares to distract and flee. A few even shed glowing body parts, pieces of themselves that continue to shine as they drift away, leaving the predator grasping at light while the animal escapes into the darkness. All of these interactions, these glows, flashes, and pulses, form a kind of unspoken dialogue among species. It's a constant exchange of information, a visual language in a world without sight, and it all serves the delicate dance of life in the deep sea. where every calorie counts and every decision can mean the difference between survival and disappearance. But the balance goes even deeper. Bioluminescence helps govern vertical migration, one of the largest synchronized movements of life on Earth. Every night, billions of creatures, many of them bioluminescent, rise from the deep to feed closer to the surface. They follow the cover of night, using darkness as protection. But even then, light plays a role. Some fish and squid flash briefly to confuse predators during the journey. Others glow faintly to signal their presence to members of their own kind staying together in schools. The ascent and descent are coordinated, measured. Creatures feed, interact, and then retreat again to the safety of the depths before dawn. Light helps guide the way. Light shapes the rhythm. In this ecosystem, nothing is wasted. Even light is carefully budgeted. It takes energy to glow, and energy is scarce in the deep. So creatures must choose carefully when and how to shine. Bioluminescence is never used frivolously. It is only ever deployed when it increases the chance of success, of eating, escaping, mating, or hiding. This economy of light reflects the broader economy of life in the deep sea, deliberate, efficient, and deeply interconnected. And that's what makes it all so humbling. From the outside, the deep ocean might seem like a cold, empty place, black and lifeless. But in truth, it is filled with interaction, connection, and coordination. It is an environment shaped not by chaos, but by delicate relationships, each one contributing to a larger, harmonious system. Even humans are connected to this system, whether we realize it or not. The deep sea helps regulate Earth's carbon, circulates nutrients, and supports global fisheries. The glowing plankton we admire in coastal waters are part of the same vast web that includes deep-sea creatures we may never see. The balance of light and life down below affects the surface in countless invisible ways. And so, in a very real sense, the bioluminescent patterns of deep-sea creatures are not just part of their survival. They are part of our survival too. They remind us that life, even in the most hostile places, finds a way to coordinate, to adapt, to thrive, and to do so beautifully. They remind us that balance does not mean stillness. It means movement with purpose, glow with intention, action with awareness. In a world where we often equate brightness with dominance and success, the deep ocean offers a different perspective. It shows us a system where the faintest lights matter most, where subtlety wins, where survival depends not on outshining others, but on glowing just enough in just the right moment to be understood or to disappear. In the grand, quiet depths, the balance of life glows softly, patiently, constantly, and perhaps, in its measured pulses of light, it whispers something to us, a lesson about the power of gentleness, the necessity of harmony, and the wisdom of shining only when it truly matters. Imagine for a moment the deepest place you can possibly conceive, not just dark, not just cold, but a realm so distant from our everyday world that it feels like another planet entirely. The deep ocean trenches, places like the Mariana Trench or the Kermadec Trench, reach nearly 11,000 meters, 36,000 feet, below the ocean's sheet and surface. These are places of crushing pressure, frigid temperatures, and utter darkness, a kind of abyssal silence where no sunlight has ever reached, not even in the earliest days of Earth. And yet, even here, in this unimaginable blackness, there is light. Not sunlight, of course, but the strange, delicate internal light produced by living organisms, the final frontier of bioluminescence. What makes bioluminescence at these depths so incredible is not just its beauty, though the beauty is otherworldly, but its defiance. Life in the trenches should be impossible. The pressure at the bottom of the Mariana Trench is over 1,000 times greater than at sea level. enough to crush most human-made submarines. The temperature hovers just above freezing. Food is scarce and the terrain is treacherous, and yet scattered across the seafloor, living quietly in the sediment or drifting slowly in the cold water are animals that glow. It's humbling, really. Light in this setting is not something that travels from above. It is something that rises from within. Some of the bioluminescent creatures in the trenches are known to science. Strange, soft-bodied fish, like the cusk eel or snailfish, which have adapted to survive the pressure and total darkness. Others are jelly-like invertebrates, gelatinous, translucent, and filled with cold, gentle flashes. They float, pulse, and drift, glowing not because they need to be seen, but because they need to communicate, defend, or attract food in a world where every interaction is precious. And then there are the creatures we have not yet named, because the deep trenches are still so unexplored that every dive brings new species, new shapes, new kinds of light. The truth is, we don't know how many bioluminescent animals live down there, or what secrets they carry. Every time a deep-sea lander or a remotely operated vehicle descends into these depths, its lights reveal brief flashes, a glow that darts into view and vanishes, a flicker, a hint, a ghost of something alive. In a world where the very act of movement consumes enormous energy, light is used with caution. It's never wasted. A brief flash may warn of danger. A shimmer along the body may attract a mate. A glowing lure shaped like a worm or shrimp may dangle in front of a motionless predator, patiently waiting for a meal to come close. In the trenches, glowing is not a display. It's a strategy for survival in a world where one wrong movement could cost everything. One of the most extraordinary things about bioluminescence in these deepest zones is that it may be one of the only consistent forms of communication. In the total silence of the trenches, where there is no echo, no colour, no scent that carries, light becomes the universal language. A blinking pattern here may mean I am dangerous. A glow there may mean I am food. A slow pulse might be I'm here. Where are you? These messages are not spoken. They are not heard, but they are seen. And in that seeing, life connects, however briefly. Consider how long it took for us as humans to even discover these depths. Until the 50s, we had no way of reaching the bottom of the ocean. It wasn't until the descent of the bathyscaphe Trieste into the Challenger Deep that we confirmed anything could even live down there. And yet, when that vessel reached the bottom, what did the explorers see? Not nothing, not emptiness. They saw life, life that shimmered, drifted, and pulsed with the same quiet dignity as creatures in shallower depths, only more secretive, more refined, more ancient. In fact, bioluminescence in the trenches might be one of the oldest survival tools on Earth. It may have evolved in deep marine environments long before complex eyes or brains existed. A chemical reaction, luciferin reacting with oxygen, triggered by an enzyme called luciferase, is all it takes to create cold, living light. It is simple, it is ancient, it is resilient, and it has lasted for hundreds of millions of years, shining through extinctions, tectonic shifts, and changing oceans. It's possible that some of the first signals exchanged between multicellular life forms weren't sounds or scents, but flashes of light in the water. That makes the bioluminescence in the trenches not just rare, but sacred. It is a living memory, a relic from the deep time of our planet, still flickering in the most hidden corners of the Earth. And perhaps what's most astonishing is this. Despite the crushing pressure, the cold, the dark, and the isolation, life has not only survived, but it has found a way to shine. There is poetry in that. In a world that seems from the outside so empty, life glows with purpose. It glows without witnesses, without applause, without reward, just a slow, steady shimmer in the black. A defiant whisper. I am here. I exist. I am part of this world. And if life can glow in the deepest part of the ocean, in the coldest, most hostile crevice of the earth, then maybe it can glow anywhere. Maybe it can glow in us, in the quietest parts of our hearts, in the places we think are too dark, too cold, too forgotten. Bioluminescence in the ocean trenches isn't just a scientific wonder. It's a metaphor, a promise. In the places where no light reaches, light can still begin.